Actually, we can start because nobody cares if they missed the demo of the who I am. So we're thanking our sponsors. And yeah, this is the, if you came to this session and you don't know who I am, thank you very much. I'm Joel Bennett. I'm from Western New York by way of Guanacaste, Costa Rica. I have been J-Cool online since like the 1990s. And I'm currently principal DevOps engineer at Lone Depot. Yeah, that's enough. So, well, I'm pressed for time here, man. So we're going to talk about Poka-Yoke today. What is Poka-Yoke? The phrase comes from the Japanese words poka, meaning mistake, and yoke, meaning avoidance. So the goal is mistake avoidance. The term was coined by Shigeo Shingo at Toyota as part of their zero quality control stuff. And it refers to a set of techniques and tools used to prevent errors or defects. They're obviously focused on manufacturing cars, but we don't really care. It's a cool idea. Incidentally, random trivia, they originally called it Poka-Yoke. Baka means idiot. They changed the term to be a little less insulting. So let's do this. Where do bugs come from? Bugs, defects, problems. Where do they come from? People. How about mistakes, right? Obviously, you didn't do them on purpose. So they're never on purpose. They're always the result of mistakes. I think to prevent bugs, we want to prevent mistakes. And if we do it well, then we can improve our user's experience at the same time. Now, let's be upfront. We can't prevent all mistakes. So the goal here isn't to prevent every mistake. The goal is to prevent mistakes you've seen before. Does that make sense? So we're trying to prevent humans from repeating mistakes. As part of the concept of Poka-Yoke, our goal is to design tools and processes in such a way that human mistakes are immediately detectable or basically impossible. So I've got some real life examples here of industrial Poka-Yoke. And now that you've heard this term, you're gonna see this all around you. But here's the bottom of these are the best kinds of Poka-Yoke. They're easy to implement. They require no maintenance. They don't slow you down. But most importantly, they make it almost impossible to make a mistake. Not only can you not plug in your HDMI cable upside down, you can't plug your HDMI cable into your USB port. So when there's no way to actually totally prevent a mistake, the next thing in Poka-Yoke is to make the mistake immediately obvious. So the warning lights here are an example of that, right? It helps you when you get in your car, you turn the key and the gas light comes on and it beeps at you. You're like, oh yeah, maybe I should stop and get gas before I go on my road trip. So that's the kind of stuff that we're looking at doing in PowerShell. So I wanted to start this by doing a reminder. Those of you who are really new to PowerShell, this is gonna be you're gonna take a picture at the end. And those of you who have been doing PowerShell for a couple of years, you're gonna be like, yeah, whatever. Jeffrey Snover always used to say that they tried to design PowerShell to make it easy to do the right thing and hard to do the wrong thing, right? Microsoft likes to talk about the pit of success, right? People falling into the pit of success. So a big part of that for us is consistency. The reliability in PowerShell, a big part of making things error-proof is that people can look at a command and guess what it's gonna do. And so that logical coherence, that single way of doing things. So if we have a mandatory parameter, we have one way of doing mandatory parameters, right? So as tool authors, we get to take advantage of a lot of work that Microsoft did in the design of the product. So we're gonna go, because time, we're gonna go through these really fast, right? I guarantee you for every single bullet point up here, if you put it into Google, you will find a whole page on learn.microsoft.com about this topic. I tested all of them. And I tested them in incognito mode. We have a set of approved verbs, right, that help us identify what a command is going to do. But on top of that, we have guidelines for picking nouns. I'll give you a hint, by the way. Pick a noun that matches the object type that you're outputting. We also have a set of common parameters that we have help from the engine to implement, so we don't have to do any of the work. Those help everybody not only understand your commands, but test them and use them safely, right? Because we get what if and verbose and confirm and all that. We also have an extended list of standard parameter names and types that most of you probably don't know exist. There's over 125 different parameter names that the PowerShell team believes that are common enough that people will intuitively know what that parameter means because it's used all over the place. They're divided into 7 categories, and there are even guidelines for what the data type of the parameter should be. So this is all on the site. On top of that, we have a lot of options for validating parameter input. We'll talk about some of those in a minute. And we have, okay, because we've been so strict about the verbs and the nouns and all that, we also have aliases that will give you some flexibility back for commandlets and for parameters. This can help you to help your users when you know they're going to guess wrong about the name. You can put an alias in there and help them get it right. Now, the other thing those are useful for is when you're trying to deal with piped input and you need to match the properties on the piped input. But again, we'll talk about that a little bit more. There's a lot of tooling in the language for implementing things consistently. One example is parameter sets. If you have a really complicated command with multiple different, like you need to pass this and this, but if you pass this one, then you can't pass that one. We have design help in the language for that. It's called parameter sets. Look it up. We have design and implementation support for wildcard characters. So if you want to accept wildcards, there's an easy way to do that and an easy way to have that affect your searches and everything that you're gonna write. We have input filter parameters. This is more of a, what's the right word? This is more of a, we tell you how you ought to do it, and not how to implement it. But there is guidance on, or maybe I should say, there are standards for that, right? We all know them because it's on get child item, right? Filter, et cetera, exclude, include, right? Also, PowerShell has built-in support for binding parameters from the pipeline. We were talking about that a second ago. The pipeline binding can happen with the entire object that's coming from the pipeline or just properties that are on that object. And therefore, you should consider writing your own data classes. But if you don't want to do that, you can also extend built-in types and add stuff to them. And you can take total control over how those objects are displayed. So all this design work was done ahead of time by Microsoft to make it easier for us to write tools that our users can intuitively use and can automatically guess and do the right thing, discover the best way to use the tools that you write. So, okay, deep breaths. Let's look at some concrete examples. We're gonna look, I'm calling all of these ways to make mistakes impossible. I think you will see that some of these only make mistakes hard. So the first is always use commandlet binding. And the reason is commandlet binding gives you support for those common parameters I was talking about before, but it also makes it impossible for users to pass parameters to your commandlet that you don't expect. Because as soon as you turn on that commandlet binding, any parameter that you don't list in your param block is going to cause an error before you're invoked, right? It's going to stop them from calling your code. Another thing that we can do is strongly typing parameters, right? By saying the type, if they pass a thing that's not that type, it just blocks it. Now, check out this parameter name. Can you guys all see that code? Is that big enough? It's too dark. Oh, it's too dark. I don't know if I can do anything about too dark. Let's see. Let me think. Is that better to read? Okay, so that, again, commandlet binding, we already talked about this. So this is, now we're putting just a type on here that's called direction. But the key, and by the way, you see the enum up here, I just defined it, right? These are the directions. So I want you to notice the parameter names. One of the things that you can do to help your users avoid mistakes is pick really good parameter names. So I can change this direction parameter to cardinal direction, right? And for most people, as soon as they see cardinal direction, they know that's north, south, east, west. There's no up, down, there's no left, right. It's just north, south, east, west. They don't have to try an incorrect value or tab complete or anything because they'll intuitively know. The same kind of thing with putting distance in meters, right? If you're asking for a distance and you're trying to say a real world distance, if you just say distance, how are they gonna tell you whether they mean feet or meters, right? They're gonna get all confused. It's easy to just say, oh, specifically in meters. Now, I will say this, we have weird choices in that because you have to choose meters or feet, and that is gonna be hard for somebody. But the general rule is it's still better because most people in the US kind of know a yard, meter, it's kind of the same, close enough. So you can get those kind of estimates without them having to think about what is the unit, what is, go look at the help, etc. So carefully choosing parameter names. Validation attributes, right? So if you haven't seen these before, there's a whole set of them. I've got the only ones I care about on here. There's more, but validate set lets you put a list of things in. So one thing that I will point out is in this case, a validation attribute can do some of the same things as a strongly typed parameter. By putting validate set on that direction thing, right? This is my direction, my cardinal direction parameter. By putting validate set on there, I've got the same thing. They can only put north, south, east, west. I can make my type a string, right? And they still can only pass those specific values. The cool thing about validation attributes is you can do more. So a validation script, for example, can look at the values of other parameters that come before this one in the parameter block. So this example that you see here is doing if the cardinal direction equals north, because it knows what you passed for the cardinal direction when you're doing the IntelliSense. I'll show you a little bit about the implementation. The imaginary scenario here is we're working with a 9x9 square board, like a checkerboard, and we can only move in straight lines. So that's the imaginary. So the thing here is you can't move past the edge of the board, right? So that's the validation script. The point is that with this in place, when you're tab completing or trying to put in an entry, right? I could say I can validate the range to 1 to 8 because obviously I know the board is only 9, so you can only move 8 in any direction. But if I put the validate script on, I can also detect if you're in the middle, you can't go 8, right? Okay. So, tricky. Okay, I'm gonna go to the next slide. Argument completers are another way of helping people. Argument completer is a way of enhancing the tab completion. So basically you can custom take control of tab completion. In this example, which is, in my opinion, really complicated for an argument completer, I'm actually doing that board that I just described, right? And I'm checking what the X and Y position of the current player is, and I'm outputting an array of all the possible numbers that you could put in the direction that you already said. So if you said north and you're 3 down from the top, then I'm gonna output 0, 1, 2. Those are the how far you can go, or not 0, because 0 is not an allowed move. There's actually, it's funny because I had a really hard time in my head when I was writing this. And so all of these arrays actually go to 0. And then there's a thing at the bottom that takes the 0 back off because I just had a hard enough time like visualizing it. Does that make sense? But anyway, so that is how that works. Argument completers can be written this way, or You can write it with register argument completer, which is a commandlet that you can write it. That means you can write it for other people's commands, but it also lets you put it in your modules or your scripts at the bottom and have it set it up. Now there's two others down here. I did like a honorable mention at the bottom. I validate I hate the name of this thing. I validate set values generator. It is a interface that you have to write a PowerShell class to implement, but it is just like validate set, except that it runs code at the time that somebody hits tab to calculate the list of possible values. So it's a little bit like this argument completer, but you understand, I hope you guys understand, argument completers only affect the tab completion. So this argument completer can't stop somebody from putting 42, right? Validate set value generator can, because it's a validate set. Make sense? So if you use a validate set value generator, I could have written this exact same thing as a validate set value generator, except that the validate set value generator does not get access to the other parameters. Argument completions is the same as validate set, except that it doesn't validate. So you can just put a simple list in there and it'll do tab completions, but it doesn't prevent people from putting additional values. So if you had, for example, some super complicated thing where you're like doing input of, you're expecting people to put their usernames, but you already know what all the usernames of everybody that works here is, you can put that in a argument completions. And if somebody new joins, it won't stop them, and you'll just have to update it later so that they get tab completion for their own name, right? Okay. You can combine like all of these. There are some weird interactions occasionally. Specifically, the order matters, and it goes from closest to the variable name out, which is kind of a weird thing. I don't know if you guys know this. When you have a parameter and it has a type on it, say you have a parameter like the one that we were looking at earlier, that's an enum and whatever. If you have another parameter type that you put, so you have your variable name, you have your type. If you put another type in between the variable and the type of the variable, it casts through that. So the variable type is the last one, the one that's furthest out, or maybe highest, if you think about it that way. But input comes all the way through to that. So like as an example, let's say that you wanted to have a parameter that only takes characters, but it takes an array of characters. So you want to allow people to type that array as a string. So they can just type ABCD3 and it'll get all of that as an array. You can cast it to car array, which will take a string and turn it into individual cars. And then you can take that and cast it to string array, and it'll turn it back. And you'll get a string array. Okay, anyway, moving on. So we're going to shift gears here and talk about ways for us to prevent problems that we make, okay? So what's the best way to stop yourself from repeating a mistake that you've made before in PowerShell? No ideas? What'd you say? Tests. I love it. My answer is actually regression tests. So this is very simple, right? Every time you make a mistake, write a test that fails because of the mistake you made. Fix the mistake, and then integrate the test. And what I mean by that is make sure that the test runs every time that somebody tries to make a change to the code, right? So hopefully you have a pipeline or something. People have to open a pull request to add code, and before the pull request can be merged, the test has to run and pass. Does that make sense? This is a fairly straightforward and simple thing to set up. Obviously, it can be implemented entirely by hand. But the key thing is to say, every time that we find a problem, we write a test to make sure that we don't put that problem back later. Over time, you build up like a collection of these, which will not only prevent you from repeating mistakes, but it will, let me say it this way. But if you label them well, it will serve as a roadmap for new contributors to be able to see what other people have done in the past, right? That can help them avoid making those same mistakes. Second thing is use PS Script Analyzer. I know that some people don't like it, but remember our definition before when we were talking about the pit of success? I put this yellow text, I didn't read it. Consistency, reliability, uniformity, conformity, logical coherence. So PS Script Analyzer is a linter. It checks for obvious errors and common mistakes that people make in PowerShell, and it helps you to identify style and consistency issues. So if you run this, like I said before, in that pull request step before you commit your code to your repository, you can avoid making a lot of different mistakes. You might file this under that category of making mistakes seem more obvious, but I like to think that the mistake hasn't been made until it's committed. So as long as we run the script analyzer before we merge it to main, we avoided the mistake, even if our junior did actually make the mistake. I'm going to go quickly because I'm running out of time. Poka-Yoke is part of the continuous improvement process, right? I said that before, that it was Toyota's thing. As part of that, we have this cycle for continuous improvement. This cycle doesn't always mean that we're iterating on the same product over and over and over. In DevOps in particular, we tend to, well, I don't know about you guys. In my team, we tend to work on what we work on tends to depend on external factors, like what management is excited about this week, or what caused the most recent outage. So because of that, we frequently can't just keep iterating on a single thing, but this process works regardless. I just realized the reason I can't use my mouse is because it's on that monitor. The problem is I'm sharing the monitor onto here, but it's a separate monitor. Anyway, so regardless of whether you're iterating this over and over on the same thing, or you just have like one cycle to iterate on this thing that you built months ago, the process is still the same. We call it plan, do, check, act. It's also known as the Schuhart cycle, and it's frankly based on the scientific method. So the first step is always identify the problem that you want to solve. Frequently, we're going through this because somebody else identified a problem. But even then, we need to understand what the problem is, right? So we have to determine why it happened, come up with some hypothesis for what the root cause is. We call that root cause analysis, and we do it using 5 whys. So 5 whys is literally just asking why 5 times. Each time you direct your why at the answer to the previous question. So let's practice, okay? Our website deployments are failing. I clicked instead of tapping. Our publish step is failing to upload. There's some sort of error authenticating to the service. I guess the credentials were wrong. I'm going to ask Bob. Oh. He says the password expired. We forgot to change the password ahead of time. So now we're actually dealing with the root cause, right? We're not dealing with, oh, you failed to log in. We're dealing with, why did you not change the password ahead of time? We just fixed this in my org by switching everything to GMSAs. Caused other problems, but don't ask me later. Anyway, once we've identified a root cause, planning is all about establishing objectives, brainstorming solutions, determining how to measure success. Right? Because that's really important. If you don't know how you're going to measure success, you can't ever measure it. The simplified single-player version, so if you guys have open source project you work on by yourself, the simplified single-player version of planning is figure out a root cause, come up with at least 2 things you can try to avoid or detect the mistake in the future. That's it. There might be some things that you can try that we are on that list that we just discussed, right? Script Analyzer, you might be able to write your own new Script Analyzer rule because Script Analyzer didn't catch it. You might add additional error handling inside your command. You might try a process change like pair programming or using an AI coding assistant, whatever. So when you get to do, this is about experimenting. Design and test those mistake mistake-proofing solutions. Run your tests, measure the results. Finally, check. I said finally, this isn't finally. I'm ahead of myself. There's 4 steps. Check, study the results. Compare the solutions. We came up with 2 ideas. Which one's better? Verify that one of them actually made things better. And then act is about implementing the best solution. And what we mean, you may have already written the code in the do and check, right? But what we mean here is make it permanent. Merge it into main, document it, and train your people on how to use the new thing, whatever it was. Okay. So 2-minute summary of design tools. Plan. We're writing a function now, okay? We're going to do our planning by writing examples. We're going to say, I want to be able to use it this way. I'm going to put an example. Where I'm going to write that example down is I'm going to write it in the code with a dot example above it so that it shows up in help, right? We're going to put them as a comment, right, in our help. Then we're going to treat those examples as if they were tests. And we're going to write the code to make those tests work. Check, we're going to write regression tests to make sure that our examples always work. Now, I would love to generate my help examples from pester tests. I'd love to be able to write a little pester test, put a tag on it that says example, and have PowerShell take that and put it into my help. But we don't have these kind of fancy tools right this second. So what we do is we just write an example, and then we write then we write a pester test and we name it example 1. And then we write another example and we write another pester test. We call it example 2. And then whenever anybody changes the comments or the tests, you have to check and make sure they still match. Because the thing that happens a lot of the times is people fix the tests, but they don't fix the help. And now your help is out of date, right? So don't let that happen. Finally, document. When I say document, when I'm talking about a function, I'm talking about describe the command. Do you guys all recognize that these are keywords for the help, right? Describe the command. Write a short synopsis where we clarify the meaning of the verb and the noun, okay? Because you use a verb and a noun and you're very sure everybody understands what they are. Your synopsis is where you make sure that everybody knows what the verb and the noun are and how they relate to each other. Your description can be really long. I make sure there's a helpful description in the comments above each parameter, and then those show up as parameter help. And finally, I add a dot link. Sometimes I add dot links to related commands. Other times I add dot links to URLs. If you add a dot link to a URL, PowerShell will automatically use that when somebody types get help-online. So you don't have to do the whole online help thingy in the commandlet binding. Last thing, really last thing. How do we detect mistakes? So we were talking about the whole point is to avoid mistakes that we know about. So this is how we find out about mistakes, right? The first thing is I should have covered this earlier. If you know about a mistake, to mistake proof, you write an error like this with the -recommend and you tell them what to do about it. Because that shows up in the error in your terminal. It says, hey, recommendation, do this. And then the last thing is when you have an error that you don't know what to do, write error information, log it essentially. Now this, I'll have all this code on my repo. It's jcol/DevOps 2025. It's private right now, so you can't see it, but I'll make it public later. The idea of this, you see the right error here? It says, recommend. Please consider reporting this issue at my repo name. Include as much information as you're comfortable sharing from my game _error information, blah, blah, blah. What I did in the line above is I called it write error information. Inside write error information, I write a bunch of stuff to the information stream, and that gets captured in that information variable. So now I've logged it to their screen. If they have information action continue on, it shows up on the screen. Otherwise, it doesn't, and they just get this error that says, hey, this happened, please consider. But the key thing is that the variable has been set, and they can actually set that to the clipboard and paste it into my GitHub issue. Make sense? That's all I got. Except for, did that go? No. Except for that.